I believe it's question number 5 on your sheet. I had edited it but forgot to do that here. It's the same question that we just looked at in question 4, but it's asking something different this time. So the same setup, different question. The ball is still rolling up the ramp with an initial velocity of 6 meters per second, accelerating at -2 meters per second until it comes to rest. So if we recall from question 4, we can, again, we're going to put our velocity in meters per second on the y-axis, time is on the x-axis, and we're going to go up by 2s again. So there's 1, 2, 3, 4, 5, 6. So that's my 6 meters per second. And if we recall from the other one, we can remember that this was going to be 1, 2. It comes over in 3 seconds, and it comes to a rest in 3 seconds. So I'm just going to graph that line again, something like this. Okay. And now, just to take a peek here at what we're asking, again, we've got a velocity of 6 meters per second to start, comes to rest with an acceleration of -2. That means it's slowing down. Now we're asking, though, how far did the ball roll? So we have to think to ourselves, what does that mean? And how far means that they want a displacement. So that's what we're looking for. Now, you can think back to, I think it was question 2 at the beginning of this, or we can look at the units to figure out how to deal with this. So we've got meters per second and seconds, trying to find meters. In the last one, we divided because we were looking for meters per second squared, but now we need to just look and see what these units are doing. So we've got meters per second on our y-axis, and we've got seconds on our x-axis. And if we take a look here just to kind of get a feel for this, and we look at these units, if I've got seconds on the top and seconds on the bottom, those are going to cancel out, and indeed that's going to give you a unit of meters, and meters is a unit for displacement. So we did this in question 2, but we're going to look at it down here. So in that one, we had a constant velocity, so we just found the area of the rectangle. In this case, we don't have an area of a rectangle, but if we look carefully, the shape between the curves, or the curve, that's the blue line, the graph, and the axes is now a triangle. And in the same way that we did in question number 2, where we found the area between the graph and the axes, we're going to do the same thing here to find the displacement. Because the velocity is changing, it's covering less time per second every second, so that's why it's coming down as a triangle as opposed to over like a rectangle. So just like we did in the other one, we're going to find the area under the curve. Now we've got an area of a triangle. You'll recall from geometry that area of a triangle is 1/2 the length times the width, or the base times the height. So we can take a look here and figure out what those values are going to be. So the length of this triangle, we could call maybe this one here. That's going to be 3. So we've got 1/2 of 3 seconds times our height, or our width, of 6 seconds, or 6 meters per second. Sorry about that. And we can go ahead and do that easy math here. 1/2 of 6 is just 3. So it looks like it's going to be 9. The units, again, the seconds are going to cancel out, and we've got 9 meters, and that is our displacement. That means that the ball that's rolling up the ramp, starting at 6 meters per second, decreasing speed at a rate of -2 meters per second every second, rolls 9 meters as it's coming to rest.